Welcome to Logue. My name is Jeremy. Today we're going to be talking about the project structure of a Korg Logue-SDK oscillator. Yeah, let's just jump right in. Yeah, so the first thing you're going to need is some sort of text editor. I'm going to use Atom. It's free, it's open source. You can get it on Windows, Mac, Linux. You can get it on a lot of different platforms. You basically just head over to atom.io and download that tool. Next thing I think we should probably do is head over to the Logue-SDK GitHub. That can be found at this address here. I'll put a link in the description for convenience. And then we're going to just click on this oscillators tab and basically walk through this project structure, taking a look at a demo, at the waves demo. Yeah, so let's just open up Atom. Right, so here we have sort of our project structure. We have the Logue-SDK top directory, and then we have all the subdirectories within that. Again, today we're just going to be looking at the waves demo and just sort of like trying to understand the file structure. So that can be found in the parent folder under platform, Minilogue-xd, demos, waves. And all I've done here is just make a copy of the original waves file, the original waves folder, and then just copied that and renamed it copy. And the reason I did that is because I wanted to edit stuff and put in comments without really messing up the waves file. I mean, you can download it again, but so the first thing that I think we should talk about is sort of like what you need. And you basically need at least 5 things. Maybe you can get away with 4, but you really need at least these 5 things. You need a makefile, the manifest JSON, the project make, and then a C or C++ script, and then a header script. And I tried to like, I'm not a C coder by any means, and I'm trying to get a handle on sort of how this file structure looks and what each part does. So I sort of created a cheat sheet here. And basically the manifest JSON file is the instructions for the plugin loader. The project make file is sort of the local modifications that you're making to the make file. The other thing I've done that I think could be helpful is understanding where each file uses which, how does the C++ file use these other files, and where does everything fit in? So for example, the C++ file uses the header file at line 42. So if we take a look at that, boom, here, head down to 42, you can see that it includes the header file right there. Same thing can be said here. So the make file uses the manifest JSON file as well as the C++ file via the project make file. So that kind of looks like this. So if you head to the make file at line 96, you should see where the manifest JSON file gets used. The same thing can be said here. So the make file uses the C file, the C++ file, but it uses it via the project make file. So if we go to project make in the make file, line 41, here we go, and line 108. This is sort of via the make file. And then, of course, if you go into project make, you sort of define that source here. So you're saying, use the source file for C++, and then that gets called at line 108 in the make file there. Right, so that's kind of how these 5 files work together. And if maybe, if you're familiar with C and how sort of this sort of all fits together, sorry, but this is me kind of learning how each of these points sort of connect to the other and work together. So from that, we can head back over to here and sort of take a look at the project structure. So the manifest JSON basically consists of a dictionary. And if you're familiar with Python, you might be familiar with dictionaries, but basically, anywhere you're going to see platform, login, or load in this text. For module, load in oscillator. For API, blah, 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 blah. The key things, though, are name. You're going to want to change the name so that the name of your oscillator, shows up in the right place. And then the number of parameters and sort of those definitions as well. And we can take a look here again at the manifest JSON here. So for the manifest JSON for the waves demo, it's the platform is Minilogue-xd. It's an oscillator. Here's the version, the name, and then the parameters. So it's just like basically just like the website. The next file that you want to take a look at, or that you're going to want to edit, is the project makefile. And basically, you'll have a project name, and this name is going to be the name that shows up on the device, because this project variable gets called in the makefile when it comes to naming the setting the name on the unit. You can also you can code the oscillator in C or in C++, and in which case this would be something like waves.c. It wouldn't be C++. At any rate, this is where you sort of define where the makefile should look for the C++ file. There's some other things in here, and we can look at those. So obviously you have C source files, C++ source files. You have the header search paths. You have a custom GCC define flags, and then linker library for flags. This is like a little more advanced. We won't be really using any of this anytime soon for sort of our first oscillator here. The next thing is the core API. And this is really like the bulk of what you're going to be coding. A lot of this manifest JSON, this project makefile, these are going to be like just really quick. You just sort of set the name, set the parameters, and then move on. But really, the meat of this is this C++ file, and that's what this core API is talking about. Right. So these are the libraries. These are like basically the core libraries you'll need for the type of oscillator or effect you're developing. And basically this is an oscillator library. The next thing is the oscillator initiation command function. And this is just going to be executed once per voice when the oscillator is loaded. So this sort of just like tells the machine this is the oscillator we're going to be using. I'm going to skip down. So we have the initiation. This is the initiation of the oscillator. I'm going to skip down to this note on and note off. And then we'll come back to this oscillator cycle here in just a second. Okay, so anytime you press a key on the keyboard, the oscillator note on function is sort of going to activate, and essentially it resets the oscillator to the 0 position. And then the same thing happens, or a similar thing happens when you take your finger off the keyboard, and it initiates this note off function. Basically, there's nothing in the note off function. It basically just says stop making sound. The next one is the oscillator param. So this is called whenever a user changes a parameter. So what this section is doing is anytime you turn a knob, it's going to store that value in memory. So if I change a feature, it's going to note that I changed the feature and save the position that I changed the parameter to. Okay, and finally we have our oscillator cycle. This is really the bulk, like the meat of the script that you're going to be running. And this is where, as the API describes, this is where the waveform should be computed. This is the function that's called every time a buffer of frame samples is required. That's one sample per frame. So samples should be written into the y-in buffer, and output samples are formatted into the Q31 fixed point representation. So that looks a little bit like this. So we have some buffer. Again, it's this y-in buffer. This is the thing that gets filled. And then that has a size of frames. And then you sort of basically do some calculations. And then your output is here. And this is where your buffer will get output into that Q31 state. So that's the general structure of the oscillator and sort of all the parts that you're going to need to put in. I think in the meantime, copying and pasting, some of these demo files, like the sine, or these sort of test files, like the sine wave or the square wave, and then making sure you have everything that you need in one folder before executing the make command. That's gonna get you pretty far. Yeah. So in the next one, maybe we'll walk through an effects file structure. It's very similar. It's going to be basically the same. And then I think we'll try to make our first effect. We'll see how that goes. All right. Thanks for watching.